started recording. Okay, so welcome everybody to this. So this particular session would be on evaluation measures, and mostly there is only one question I found that is on boosting. So primarily this is on evaluation measures. As always, and as has been told by the NPTEL people, I'll go through the questions, and if you have any doubts in between, you can stop and ask me. And towards the end, after I finish the questions, I will be open to questions as well, so you can stop me and ask questions wherever you feel like. So these questions are pretty simple, so you can just I'll just go through them, and again, if you have any doubts, you can stop me and ask. Okay, so the first question is, oh, this is pretty big. Change color. Yeah, so the first question is, you have two binary classifiers A and B, and A has accuracy of 0% and B has an accuracy of 50%. Which classifier is more useful? So see, what is happening is, if B has an accuracy of 50%, that means ideally, so in this case you might consider a data set like let's say a dog cat classifier, whatever, a simple binary classifier. So you have 10 examples, out of which 5 are dog and 5 are cats. So these are your true labels, and suppose you have predicted all of them to be dog, right? These are your predicted labels, and this will be your predicted labels for B, because you see in this case it will be 50, or your classifier will be 50% accurate. For the classifier A, what you have done is, you have predicted exactly opposite. So you have predicted all the dogs as cats and all the cats as dogs. So this is your predicted labels for A. So I mean, this might seem very counterintuitive to you, but if your accuracy is actually 0%, that means your labeling somewhere probably has gone wrong, due to which your dogs are appearing as cats in the in the case of the classifier A, and your cats are appearing as dogs in your classifier A. And just by flipping those labels, you can make it 100% accurate system. So if you just flip the labels of all the predictions for the classifier A, you would see that your classifier A will now have an accuracy of 100%, and therefore which classifier is more useful? A would be more useful. Okay, I hope that was clear. If you have any doubts, you can stop and ask me. Okay, now the next question is a same question but in a slightly different setting. So now we have multi-class classifiers A and B. So multi-class classifiers means, for a binary classifier you have two ground truth classes. I mean it may be a cat and dog classifier, for example. For a multi-class classifier, it can be more than two things. So for example, if you have an emotion classifier, so it can be you can be sad, happy, angry, neutral. You can have 4 classes, 5 classes, 6 classes, 7 classes, and so on. So those are multi-class classifiers. So A has an accuracy, it's the same question. So A has an accuracy of 0% and B now has an accuracy of 50%. Which classifier is more useful? Now here you see what is happening is, let's say I have class 1. Okay, let's consider I have 3 classes and I am classifying emotion. So the S stands for sad, H stands for happy, and A stands for angry. So these are the 3 emotion classes that you want to predict, and so these are your ground truths. These are your ground truth classes, and A has predicted, let's say every sad A has predicted as happy, every happy A has predicted as angry, and every angry A has predicted as sad. So in this case you would find that it has suppose this is your prediction of A, and in this case you see that if you replace happy by sad, angry by happy, and sad by angry, you could potentially get 100% accurate system. But while this is one possible case, another possible case is, let's say this is what has been predicted by your classifier A. This is also one possible prediction, in which case your accuracy will be 0%. So 0% is in both cases. However, in this case, just by flipping of the labels, there is no way in which you can get a 100% accurate system, right? So it is very difficult to say that A would be so it is very difficult to understand whether A is a useful classifier or not, depending on either of these two results. And therefore, and B has an accuracy of 50%. So while you see here, like in the first case, you had a binary classification, there B had an accuracy of 50%, means B had predicted every example to be of the same category, and therefore B is obviously not useful in that case. However, in a multi-class classification setting, if you have 50% accuracy, that means, so here if you had predicted everything as one particular emotion, you would end up with an accuracy of 33%, 33.3%. But B having an accuracy of 50% means that it is doing at least better than random, and therefore we cannot say anything about this particular setting. A can be useful, B is definitely more useful than random, but whether B is more useful than A depends on the situation, depends on the particular use case, and therefore the correct answer for this would be cannot say. We cannot say which classifier is more useful based on the information that has been given in the question. Okay, then coming to the next question, using the bootstrap approach for sampling, the new dataset will have what percentage of the original samples on expectation? So bootstrap sampling is like, so let's say you have a dataset, this is your dataset, and you create multiple such, and this dataset has a size of n, and you create multiple such datasets, each of size n. So all these datasets are of size n, all these circles are datasets of size n. And how do you create these datasets? It's like you select, so the original dataset has n points, you select each of those n points with a probability of 1 by n, and you sample the same, you sample from the same dataset points and create these datasets of the same sample size n. However, you sample with replacement. So ideally what can happen is your same point can come into this particular dataset multiple times. So what is the probability of let's say one point getting selected in the first dataset? Let's say in the first bootstrap sample what you create, what is the probability of one particular point getting selected is 1 by n, and therefore what is the probability of that point not getting selected in this particular in the first particular bootstrap sample is 1 minus 1, it's 1 minus 1 by n. It's 1 minus 1 by n, and therefore if you have 1 minus 1 by n, and therefore if you have n such samples, the probability of one particular point not getting selected in any of the n different bootstrap samples is 1 minus 1 by n whole to the power of n, correct? So this will be the probability. Now expectation means if n is a very large number, so if n becomes so let's say if n goes to infinity, then the limiting value of this, if you work this out, so this will turn out to be 1 by e, where 1 by e, and this would be ideally around 36.7%. 36.367. So in percentage terms it will be 36.7, and therefore in the bootstrap approach the new data set will have, so this is the probability of a point not getting into the data set, at all, and therefore the probability of that data, the new data set will have 1 minus or 100 minus 36.7% of the points while it is being created in the bootstrap approach, and therefore that comes out to be 63.2. I think this was told directly by the instructor in the course. So 63.2 is a number, and that particular number comes in this particular fashion which I have shown. Okay, so I'm going on with the questions. I'm not getting any questions from your side, so I'm assuming that you are understanding everything. Okay, so to the next question, you have a special case where your data has 10 particular classes and is sorted according to the target labels. You attempt 5-fold cross-validation by selecting the folds sequentially. What can you say about your resulting model? So you see, what is happening is you have your data has 10 classes. So let's say I have just 10 data points. I mean, you ideally would have much more data points, but just for showing, I'm showing that you have 10 data points, and these are the classes of the 10 data points. So these are your classes, and these are your data points. You have 10 data points, and these are your classes C1 to C10, and they are sorted according to the target label. So let's say these are the target labels C1 to C10, and they are sorted in this way. You attempt 5-fold cross-validation by selecting the fold sequentially. So 5-fold cross-validation means you would so 5-fold cross-validation means, let's say you will have 10 by 5 is 2. Okay, so in the first case you would have all these as the training data and these two as the testing data, let's say. Okay, in the second case you will have C2 to C9 as the training data and C1 and C10 as your testing data, and so on. So you can understand how this will go. Next case you will have C3 to C10 as your training data and C1 to C2 as your test data, and so on. So I hope you are getting the point how this cross validation is being done. So in this way what will happen is, for example, let's say I am taking the first fold itself. So C1 to C8 will be my training data, and C9 and C10 will be my testing data. Now when you train your models on C1 to C8, your model doesn't even know that C9 and C10 even exists. You don't have any data point for which the ground truth label would be C9 or C10, and therefore your model will never predict any particular data point as C9 or C10, because it has not seen any such point during training, and therefore it won't predict any of those particular classes. And this would happen for all the cases. Like whenever you have C3 to C10 as your training data, your model won't be able to predict C1 and C2, and therefore your model will have 0% accuracy, because it won't ever predict. It doesn't even know what the classes that you are asking it to predict exists in the data at all, exists in the training data at all. Therefore it will have a 0% accuracy. I hope this was clear. Then coming, there's a slight calculation for this. We have predicted positive and actual positive. So this is a confusion matrix that has been given to you, and predicted negative and actual negative. So here okay, because nobody is interacting, I might as well ask one question. So can somebody say what is the true positive in this from this confusion matrix? Correct. What is the okay, what is the true negative? true negative, it means I have predicted negative and the actual is also negative. So you are saying 45, 20 is the correct answer. You see, here you have actual negative and predicted negative, so that is why 20 would be the correct answer, right? Okay, false positive. False positive is 15. You have predicted positive, but it is actually negative. So you have predicted it to be falsely positive, and therefore that is 15. Finally, false negative is 45, because that is the only number left, and also that is you have predicted negative and it is actually positive. So these are your 4 numbers that you require for this precision recall. So precision, if you recall, precision, if you remember, then it would be true positive by true positive plus false positive. So precision means out of all the numbers that you have claimed to be positive, how much are actually positive. So in your prediction of positive, how precise you are in your prediction of positive, that is denoted, that is calculated by precision. So that would be given by 35 plus 15, which is 35 by 50, which is 0.7. And recall is out of all the things that were positive in your data set, how much have you actually set out to be positive, how much you could classify to be positive. Okay, so the denominator would be true positive plus false negative, because these are the total number of positives that were actually there in the data set, and you have predicted this to be the positive. So this would be 35 divided by 35 plus 45. So 35 by 80, if I am not mistaken, 35 plus 80. Okay, so that would be 7 by 16. So 7 by 16 would be 0.4, then 60. Okay, so this will be 0.4, sorry, 0.43, and then 60, 12, it will be 7 something. Okay, let's see. Yeah, okay, so it would be 0.7 and 0.4375. Okay, I calculated 0.7 and 0.437. This would probably be 5 towards the end. 112, 80. Yeah, okay, this would be 0.4375. Okay, so AUC for your newly trained model is 0.5. Is your model prediction completely random? So if you go through the lecture, the instructor has shown something like this, that this is your AUC curve. I think this is true positive rate and this is false positive rate. So this is your perfect AUC curve, and this is completely random. If your AUC curve is like, if your ROC curve is like this, then this is completely random, because this is the case where true positive is exactly equal to false positive rate. However, here what you have been given is AUC is 0.5. So you can have something like this. Yeah, you can have something like this, and your area might as well be 0.5. You can also have this. You can also have this particular thing, and your area is also 0.5. So it is very difficult, and this is not random. This curve is not random, but this curve is random. So so the ideal answer for, so the answer for this would be ROC curve is needed to derive this conclusion. Unless we have the ROC curve, we don't know whether something is random or not. Just by the AUC, looking at the AUC, we can't say anything. Okay, then what is the effect of using bagging on weak classifiers for variance? So this is directly from the lecture. It will reduce the variance. Why? Because you are taking multiple classifiers and you are taking the average of all those classifiers. So whenever you take average of many things, the variance will ideally come down. So reduces the variance is the correct answer, and this is the reason for which bagging has been used basically. The next two cases are about building models. So what would you do in order to, while building machine learning models, you would need to evaluate them. So which factors should you focus on while evaluating your models depends on the particular task for which you will be using the machine learning model. So let's say you are building a model to detect cancer, and which metric would you prefer for evaluating your model? So of course MSE is not a correct answer because this is a classification model, so MSE is not even a question. Accuracy is not a question because thankfully the number of people who will be diagnosed with cancer would be much less as compared to people who are diagnosed with cancer, and therefore accuracy is also not a correct metric. Now sensitivity and specificity. So sensitivity is nothing but recall, and specificity is true negatives divided by true negatives plus false negatives, right? So you see, when you are building a model to detect cancer, you would focus on the persons, your model should focus on persons who are actually infected with the disease, because you would want to detect that disease with high accuracy, and therefore your model, you should focus on picking up all the positive examples from the dataset and predicting them correctly. And as I said, recall is true positive divided by true positive plus false negatives. So this is an ideal metric for this case because this shows that out of the positive examples, how many have I been able to capture? Okay, so therefore in this case sensitivity is the correct metric to look for. You are building a model to detect cancer. Your model should have a high sensitivity, that it should not miss any positive examples. Okay, then the next case is you are building a model to detect a mild medical condition which for which further testing is extremely expensive. So which metric would you prefer for evaluating your model? So of course again accuracy and MSE is not even a question, and for medical cases you should never use accuracy because your data will be highly skewed towards one of the two directions, so you should never use accuracy. So for which further testing costs are extremely expensive. So what does that mean? This means that if you are saying someone to be negative, you should pick out all the negative cases very well, because if you are saying someone to be negative, then that person doesn't have to go and take the next test for which he or she has to use a lot more money, and therefore your test should be very accurate towards the negative persons who are testing negative for the medical condition. And since your medical condition is mild, therefore you don't care whether, even if you say someone to be negative, he or she is actually positive, but you have said someone to be negative, then that is also fine because the medical condition itself is mild. And therefore for this particular case, specificity, which is, as I said, true negative by true negative plus false negative, is the correct metric to optimize for. Okay. And then coming to the last question, this is directly from the class. Boosting takes many weak learners and combines them into a strong learner, and boosting determines the proportion of importance each weak learner should be assigned and weighs its prediction by it and combines them to make the final prediction. This is directly from the class, and I'm not this is A is true. Boosting takes many weak learners which are slightly better than random. They cannot be less than random, of course they have to be slightly better than random, and combines them into a strong learner, and boosting determines the proportion of importance each weak learner should be assigned and weights its prediction by it and combines them to make the final prediction. So A is true, B is true, and B is the correct explanation for A. Okay, so that is the end of this set of questions. So if you have any more questions, you can ask me. Yeah. Any questions from anybody? Hello? Yeah. Hmm. Last week I had covered. No, no, last week I had done something different. Last week, if I remember correctly, I had done, let's see. No, last week we had done this particular assignment. Ha ha ha. No, on Monday I had done this particular assignment which I am showing right now. No, this particular assignment which I am showing right now, this is the assignment that I had done last week. It was on decision trees. No, no, somebody else. Yeah, basically we are all doing the same assignments because we have been asked to solve the same set of 10 questions. All four of us have been asked to solve the same set of 10 questions, so we are doing the same assignment. So yeah, it's basically the same set of questions, just solved at different points of time. Hmm. No, it's always the same. That's the catch, maybe. Yeah. 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 Yeah, I would no, I would suggest that if you are joining one session, I mean, the reason for these sessions being held multiple times is all people are not being able to join all the sessions. So if you are attending one session, that one session would be enough for that particular week, because we will be solving the same set of questions. So basically, this is the second time I am taking this NPTEL. Uh, yeah, this is the second time I'm taking this NPTEL course. So what? Not this course. I had taken a different course last semester, in which I had tried to solve a separate set of questions, and also I was trying to give. I mean, you would find it on my YouTube channel also. I was trying to give more insights into each of the methods. But then the NPTEL people came and said that you just solved the questions that was there in the last session. So that is why I have just left the idea that I had in the last semester, and I'm just solving the questions. So it's the same set of questions, but if you are attending one session, it's enough for that week. You don't need to attend the other sessions. Okay, okay, okay. uh, hmm, hmm, okay, 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 okay. So yeah, there must there can be one issue which I don't know why that is happening. There can be one issue is right now I am following whatever was taught in week 7 in the course. There can be a case, I mean that has been the case maybe that the person whose session you attended in the 3 o'clock session, he or she, I think he must have followed the session on, he must have covered material from week 8. So, so that for some reason I don't know why that is happening because I have not missed any session and he has also not missed any session. So I am following week by week. So I started with week 1. This is a seventh session that I am having, and therefore I am looking at week 7. So maybe what I'll try to do is one particular week I'll try to cover 2 weeks in total. Then I will also become at the come at the same level as he or he is following. Correct, correct. Okay. 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 Okay, okay. Then maybe next week what I'll try to do is I'll try to cover 2 weeks in all so that I also become so I'll try to cover week 8 and week 9 together so that I come to the same level as the course. So yeah, I'll try to do that next week maybe. Okay. Okay. Let me. Maybe towards the end. I think if I will finish. Okay. Let me see. Let me. Ha, 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 ha. Hmm. Okay. 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 Sure. 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 Yeah. Correct. Correct. Yeah. Yeah. Correct. Okay. Okay. Sure. 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 I'll try. Oh, yeah. Yeah. Thank you. Anybody else? Any questions? Okay. If there are no more questions, I'll end the call. And next Saturday, maybe as one of you asked, I'll try to cover 2 weeks in all, so that yeah. So there might be a bit, there might be more questions. There obviously would be more questions. So let's see how I do that next week. Thank you for joining this session. I'll meet you next. Yeah, yeah. That is in the chat window. If you see, I have pasted one link, the YouTube channel link. You can go there, and all the sessions are in that YouTube channel. You can just copy this link and keep it with you. Yeah, yeah. Sure. You have copied? Uh, yeah, yeah. Thank you. I'll end the call. Thank you.